one such a question which is like what I could say, one of a very good question which is asked in previous, one of a best question which is asked in previous gate, because it's a gate question which is asked in gate 2008. Most of the gate 2008 questions will be a little bit trickier, and even this question is also okay. So fine, let me go through the question. Okay, first of all, let me just recollect one thing. The longitudinal stress or axial stress in case of thin cylinder will be PD by 4T, and what is that? Circumferential stress or hoop stress is PD by 2T. Okay, am I right? And PD by 4T, we will be having my axial stress to be PD by 4T. Only, that is longitudinal stress, only will be present if both the ends are closed. If both the ends are closed. This is a concept which we learned in our course. Okay, I hope you guys remember this. So if both the ends are closed, then only what is that? Then only the longitudinal stress will get developed. Am I right? Now let me read the question now. A cylindrical container of a radius r 1 meter, wall thickness 1 mm is filled with the water up to a depth of 2 meters. So they have given us, okay, and suspended along its upper rim. So here I am attaching it. Okay, here I am attaching it. The density of the water is 1000 kg per meter cube and acceleration due to gravity is 10 meter per second square. Self weight is neglected. Okay, self weight of the cylinder is neglected. The formula for hoop stress, in a thin wall cylinder can be used, which means we can use this formula, no doubt about it, at all points along the height of the cylindrical container. Okay. Now the question is, let me first go to the first question. First question is trickier. Okay, if you understood the first question, second question is nothing. Okay. The axial and circumferential stress experienced by the cylinder wall at the mid depth 1 meter. So if I take from, that is from the top layer, if I take the mid depth means this point, okay, at this point, okay, this is the mid depth, okay, 1 meter. At this depth, they are asking us to find out axial stress and circumferential stress. So they are asking us to find out sigma A, which is nothing but sigma L, and also they are asking us to find out sigma C at mid depth. Okay. Now, sigma C, I hope there won't be any doubt at all. Even sigma A also, for most of you guys, as of now, your thought will be, as this is open in one end. See, only if it is closed in both the end, I can use this formula, I can go with this. But here it is open. Okay, here it is open in one end. So obviously sigma L will be 0. Okay. And sigma C, of course, I can find it from PD by 2T formula. This is the first thought for most of us would come. Okay, even this is the same thought which came to my mind when I seen this question first time. Sigma L is going to be 0 because one end is open, and the sigma C is going to be PD by 2T. Okay, no doubt about it. That is my first thought. And P we can determine, right? What is my P? At a 1 meter depth. Okay, at a 1 meter depth, P is nothing but rho into G into H, right? From hydrostatics, fluid mechanics. Density they given us. Yeah, density is 1000 and acceleration due to gravity is 10. So P will be equal to, so in this case, P will be equal to 1000, that is rho. Let me do one thing. Rho G into height. How much is the height? 1 meters. Okay, height is 1 meter into diameter by 2 times of T. If I solve this, I will get sigma C. Okay, there won't be any problem with sigma C, but the problem will be with sigma A or sigma L. Okay, now let us go back and understand few points. How we derived this equation. Okay, we need to understand how we derived this equation. Let me recollect it. Okay, so if I have a cylinder like this, okay, I'm filling it with some liquid. Okay, I'm filling it with some liquid. And due to, since both the ends are closed, okay, this end is closed, this end is closed, there is going to be pressure which is acting in both the ends, right? Both the closed end. Here also pressure is going to act. Here also pressure is going to act. And now if I want to find out longitudinal stress, I will cut it. Okay, I will cut it. And if I cut it, I will show you the cut section. Just consider that this is my cut section. Okay, just consider that this is my cut section. Half of the, that is half of the section. Okay, the cut section. Okay. Yeah, this is my cut section. This is my cut section. I'm cutting it here. Okay. Now here, pressure P was acting here, right? Pressure P was acting here. and the longitudinal stress will be developed. Longitudinal stress will be developed longitudinal stress will be developed over this circumference, okay, over this circumference. So the longitudinal stress will be developed over the circumference. This will be my sigma L, okay. This will be my sigma L. So sigma L multiplied by the circumference, which is pi d, 2 pi d, right? Pi d, yeah, pi into d, which will be equal, pi d into thickness. I'm sorry, I forgot the thickness. Pi d into thickness. Yeah, pi d into thickness. That will give me this area, this circumferential area, which will be equal to pressure into the internal cross section area. So cross section area is pi by 4 d square. So by solving this, I will get my sigma L. That sigma L will be 4 pi d by 4t. Okay. I hope there is no confusion in this derivation. We have done this derivation already. And now just imagine a situation where one end is open. Okay, one end is open. If one end is open, there won't be any pressure which is acting in this end also. Okay, no pressure will act on this end. Okay, because it will be free, right? See, if this end is closed, in both the ends pressure will act. Okay, in both the ends pressure will act. In both the ends pressure will act. And if I take a cross section, if I take a cut section, I can find out my longitudinal stress. But if one end is open, then no pressure will act, even no pressure will act in this section also, because it is free. It is free. Okay, there is no restriction this side. There is no restriction. If I restrict it here also pressure will act, and similarly here also pressure will act. But if I'm not restricting it, one side it is completely free, so there won't be any pressure which is going to act in this side also. And now you can ask me the question, sir, this is also the same case, right? This is also same case. Then why not sigma L is equal to 0 is not there in the option? It should be there in the option. It has to be there in the option, because sigma L is 0 here. One end is open. So if one end is open, there is going to be no pressure which is acting here. That is where our mistake is. Yes, one end is open. In this case, here pressure won't be there, because of this fluid, because of the fluid which is contained here, there is no effect of this fluid on this surface. But consider this case. Before going into this case, let me take this case. Consider this case. Sorry. Okay, let it be. I am not holding it here. See, in this case, I'm holding it in the top, right? I'm holding it in the top. But let us consider I'm keeping the container in the ground. Okay, it's a ground. I'm keeping the container in the ground. It is filled with 2 meters. It is filled with the 2 meter depth of water or liquid, whatever it is. Okay. Now say what will happen. In bottom side, pressure will be there. In bottom side, pressure will be there. Okay, pressure will be there. But that pressure is not going to cause any stress in the any stress in this that pressure is not going to cause any stress longitudinally. Why? Because the pressure is acting at the bottom side, and that pressure is withstanded by this ground. That's it. See, let me just recollect one more thing. That is, let me go back there. See, if both ends are closed, okay, if both ends are closed, both the sides pressure will be there. If I take a cross section, there will be stress which is developed, because both the sides, okay, this is also pushing this side, this is also pushing this side. So in between, stresses will be developed. But if one end is open, there won't be no pressure in this side, even though if pressure acts in this side. Okay, even though there is some pressure here, but that pressure is not going to cause any stress. That pressure is not going to cause any stress. The same phenomena here, even though there is some pressure because of the height, because of the depth, even though there was a pressure, but that pressure is not causing any stress here longitudinally. If I take a cross section, if I take a cut section, and if I see it, no longitudinal stress developed. But what about this case? What about this case? This case is something which is completely different. I'm holding it in the top. Okay, I'm holding it in the top. And of course, due to the depth, okay, due to this weight, there is going to be pressure which is acting in this surface. Okay, there is going to be pressure which is acting in this surface. If I hold it here, okay, if I hold it here, that pressure will be withstanded by the ground itself. But now I'm holding it in this place and this place. Just consider a situation. I'm just I'm going to draw a free body diagram. What if I draw a free body diagram? Remove this support, and replace it with a reaction force. Replace it with a reaction force. So pressure is acting down. So consider, like, you even don't consider that there was a support. You just consider that you are holding it. Okay, you are holding. Your hand was here. Okay, your hand was here, and your hand was here. What you will do with your hand? What you will do? You will apply some force, right? You will apply some pressure on it. You will apply some stress on it. That is, you will apply a pressure in opposite direction. You will apply some pressure in opposite direction to hold this. To hold this pressure, you will apply a pressure in opposite direction to hold this pressure. Am I right? I hope you are getting my point. Or if you are not considering the hand, you just go with physics, go with science. If there is a fixed support, remove the fixed support, there will be a reaction force. There will be a reaction force which is opposing this force. And now this reaction force, it is something like this. This reaction force is pulling it up, and this pressure was acting down. And because of these two, there will be, if you take any cross section, there will be development of longitudinal stress. I hope you got the point. Let me repeat it. Okay, finally I'll just repeat it for one more time. It's a very good question. Okay, that is what the beautiful questions which is asked in GATE 2008, and I have never seen these type of questions afterwards. Okay, right. So pressure acting here, and here I have a fixed support, right? Here I have a fixed support. I am removing that fixed support. Now this is going to offer a reaction in opposite to that of this pressure. Okay, reaction opposite to that of this pressure. Now consider taking a section here, okay, a cross section. And if you draw the cross section, I'll get a cross section like this, right? Here a pressure P is acting. Okay, here pressure P is acting, and over this circumference, okay, over this circumference, there is going to be a development of longitudinal stresses. Okay, sigma L. Got it? Okay, I hope you got it. Let me just go back. So now, how to find out the sigma L? How to find out the sigma L at a depth of what is that? At a depth of 1 meter. See, the same logic only. At a depth of 1 meter, from here at 1 meter, I'm drawing a dotted line, which means I'm finding out the cross section for that. Okay, that is my sigma L. So sigma L into circumferential, that is this area, this thickness area. So pi d into L, that should be equal to pressure into the cross section area, right? Here it is cross section area. I need to multiply with the cross section area. Here I need to multiply with the cross section area, which is pi d square. And now the question is, what is my pressure? What is my pressure here? Do I need to consider pressure at a depth of 1 meter, or do I need to consider pressure at a depth of 2 meter? Obviously, because of this pressure which is present at 2 meter only, longitudinal stress is developing. Longitudinal, even though I'm finding out longitudinal stress at 1 meter depth. Okay, even though I'm finding out longitudinal stress at 1 meter depth, the longitudinal stress is getting developed because of the pressure in its bottom. Because of this pressure in its bottom only, okay, because of the pressure in the bottom surface only, in this circumference, okay, in this circumference, longitudinal stress is developing. So what is my pressure in the bottom? Pi dl, which is equal pi thickness, right? I'm sorry, pi d into t. What is my pressure at the bottom surface? Rho g into 2 meters. Okay, bottom face is 2 meter, right? Bottom face is at present at 2 meters. So pressure at the bottom face will be rho g into 2, okay, into pi d square. So cancel all the datas. Thickness will be there, and bring pi also. I can cancel pi also, and the sigma L will be equal to rho g. I'm sorry, sigma L will be equal to rho g into 2 into d by, what is this, thickness, rho g 2. I'm sorry. Oh my god, that is what I'm thinking. It is pi by 4 d square. Why nobody said this? See, area, cross section area, pi by 4 d square. Cross section area, this is cross section area, pi by 4 d square. Okay, 4 into t. This is my final answer, okay, for rho L. And what is rho C? What is rho C? See, rho C, I want to find out at a depth of 1 meter only. Again stuck. Okay. So rho C, I need to find out at the depth of 1 meter only. Now for drawing rho C, what I should do? How I will represent rho C at this depth of 1 meter. Okay, at this depth of 1 meter, I will do one thing. I will show you separately. At a depth of 1 meter, this is what I got. Okay, this is how the pressure is acting. Okay, this is how the pressure is acting. The pressure will try to increase the circumference. Okay, the pressure will try to increase the circumference, and for resisting it, okay, for resisting it, there is going to be a circumferential stress. And in that case, my circumferential stress, which is PD by 2T, and which pressure I need to take? See, circumferential stress is developed because of the pressure at a depth of 1 meter. Okay, circumferential stress is developed due to the pressure which is present at 1 meter. So it becomes rho G into 1 into D by 2T. But longitudinal stress is developed due to the pressure which is present at 2 meter below. So this will be rho G into 2. This pressure will be rho G into 1. Okay, so when I'm finding out sigma L, I need to use P as rho G2, and when I'm finding sigma C, the pressure has to be rho G1, because this pressure, the pressure which is present at 1 meter below the free surface, is something which is causing the circumferential stress. So in most of the books, in previous year question books, even if you take a very famous institute previous year question book, directly they will give this, that's it, rho G into 1 into D by 2T. And they will say that rho L is nothing but rho G into 2 into D by 4T. But there are lots of, what is that, explanation behind this, and I hope I have cleared all the things, right? So now if I substitute it, see, both of them I am finding out at 1 meter depth only. Okay, both the values, sigma L and sigma C, I am finding out at 1 meter depth only. But for sigma L, the stress sigma L is developed because of the pressure which is present at 2 meter depth. Even though I am finding out my longitudinal stress at 1 meter depth, this is the only pressure which is causing the longitudinal stress. But for circumferential, the stress which is present at 1 meter itself causing the circumferential stress. Okay. So now finally substitute all the data. 1000 into 10 into 2 diameter, I don't remember, it's the value. Diameter is 2 times of r, that is 2 meters. Okay, and wall thickness is 1 mm. Diameter is 2, wall thickness is 1 mm, which is nothing but 1 into 10 power minus 3. And sigma C, 1 into diameter is 2, and 2 times of wall thickness is 1 into 10 power minus 3. Okay, so I can cancel this. So it becomes 10 to the power of 4, 10 to the power of 7. Yeah, here also you can cancel this. It becomes 10 to the power of 7, which is nothing but 10 megapascal, and which is nothing but 10 megapascal. So both circumferential stress and longitudinal stress is 10 megapascal. So the point to understand here is, there are two things which you need to understand. How sigma L is not 0, that is the first point you need to understand. And why the sigma L is caused, okay, because of the pressure at the bottom end, and we are holding it here. Okay, we are holding it here. So because of this reaction forces, so this reaction force will pull upward, and this pressure will pull downward. So two equal and two opposite forces. Because of that, if I take a cross section here, there will be development of longitudinal stress. And the third point you need to understand is why I am taking rho G into 1 for sigma L. Okay, I am taking rho G into 1 for sigma L because at a depth of 1 meter, rho G into 2, sorry. rho g into 2. Why I'm taking rho g into 2? Because even though I'm finding out sigma L at 1 meter below the free surface, but this pressure which is present at 2 meter below the free surface is causing it. Okay. Yeah. So that is our final answer. It's a very good question. I enjoy understanding this question. First, when I go through this question at first, when I was preparing, I never understood that. I never understood that. Okay. And after understanding it, the happiness which I had is like, it's like something, because for SIM, there is no proper person who taught me. Okay. And after understanding it by self study only, this question, the lots of happiness come into my mind after understanding this question. It's really a good question, right? Any doubts? If not, the second question is nothing. That is 77th question is nothing. Okay. Hmm, 77th question is nothing. They are simply asking us to find out the axial strain. Okay, the axial strain. So epsilon L, that is nothing but what? Sigma L by E minus mu into mu into sigma C by E. That's it. That's it. Sigma L by E I already know. Anyway, they are asking at mid depth only. So sigma L I already know. Sigma C I already know. Substituted here, I will get epsilon L. Sigma L is also 10. Sigma C is also 10. Okay.